Hi guys, how are you? I hope you all are fine. I am too glad to meet you in this online class. So today we are going to talk about universal law of gravitation. We already discussed briefly about gravitation, the force that is binding the universe. Now we are going to understand this force using some derivation. This derivation was given by Sir Isaac Newton. It is called as universal law of gravitation. So let's go to the topic. So first, before going to the derivation, let us consider this object A. This object A have the mass of m1, and object B. Object B have the mass of m2. If these two objects are separated by the distance of r, so this is the scenario. Based on this scenario only, we are going to develop the law of gravitation that was given by Sir Isaac Newton. Okay, so first of all, the first point you have to understand, every object in the universe, it may be in the earth, it may be in other planets, it may be in other galaxy, it may be in other kind of universe. Within the universe, all objects attract one another. For example, I am attracting this object and you are attracting some other object. Okay, and that object also attracting you. Just because I am attracting this object, it doesn't mean that this object don't have any force to attract me. So every object have the force to attract each and any object. This force is nothing but gravitational force. Okay, and how this gravitational force is very strong or very weak, depending on what gravitational force is more. If there is the huge mass, for example, consider the gravitational force between the sun and the earth. There is a huge mass. If there is huge mass, if there is greater the mass, greater the force. Lesser the mass, lesser the force. Consider the force between two small objects of two small masses. Then there will be the lesser force. Consider the force between two greater objects of greater mass. Then the force is greater. So this explanation was given in a mathematical derivation. So if we consider the object A mass is m1 and object B mass is m2, what is the product of these two masses? m1 into m2. So the force is directly proportional to product or multiplication of both masses. Okay, so F is directly proportional to m1 into m2. This means what? If the product of two masses is more, force is more. If the product of two masses is less, force is less. And also the force is inversely proportional to square of distance. What is square of distance? We have to multiply 2 times the distance, that is the r square. What is inversely proportional? For example, I am living here and you are in somewhere in the universe. If the distance is more, our force of attraction is very less. If the distance is very less, for example, you and some other object is very close, means force of attraction between you and that object is very intense. That is what inversely proportional means. Directly proportional means greater the mass means greater the force. Inversely proportional means what? Greater the distance, lesser the force. Greater the square of the distance. If there is greater the square of the distance, lesser the force. So that definition was given in the mathematical terms. F is inversely proportional to r square, 1 by r square. Okay. And how the force will act on the straight line joining the center of two objects. For example, consider this is the center of my object. This is center of the body, and this is center of the camera. Okay, how the force will act? The same line joining the center of two objects. This was given in this diagram very easily. I hope this explanation is enough for universal law of gravitation. Let's go to the mathematical derivation. We already saw that F is directly proportional to m1 into m2. F is inversely proportional to 1 by r square. If we combine this both equation, we can get F is directly proportional to m1 m2 divided by r square. If we remove this proportionality constant, we will get this gravitational constant G. Understand? So this gravitational constant we will be seeing in the next slide. So what is gravitational constant? It is also called as universal gravitational constant. So because we are removing the proportionality means we have to add the proportionality constant in the right hand side. Okay, so this was the basic in physical mathematics. If you are removing the proportionality means you have to add the proportionality constant in the right hand side of the equation. In this we are adding what is the proportionality constant? G. So G is the universal gravitational constant. If you further develop this equation, if you bring this r square into left hand side, this will be the equation. F into r square is equal to G m1 m2. Okay, now we have to find out the value of gravitational constant. So let us bring the product of m1 and m2 in the left hand side. Left hand side, this will be the equation. G is equal to F into r square divided by m1 m2. Okay, so this is the formula of the universal gravitational constant. Using this standard only, we have to find out the SI unit of gravitational constant. Let us consider, you see the force. What is SI unit of force? Newton. You see r square. What is SI unit of distance? Meter. As it was r square, we have to add 2m, m square. And what is the SI unit of mass? Kilogram. Okay. So your mass is, one mass is kilogram, but here the product of two masses, m1 into m2, kilogram into kilogram, kilogram square. So the SI unit of gravitational constant can be obtained by this equation. And how to calculate what is the numerical value of this gravitational constant? Okay, Henry Cavendish, he found out this value. This is the constant value, 6.673 into 10 power minus 11 Newton meter square per kilogram square. Understand? I hope this video is enough for understanding the universal law of gravitation. If there is any doubts or clarifications or thought-provoking questions, you please add your comments in chat box.